Alright, when we have 3.89 moles of a chemical, in this case ammonia, NH3, it asks how many molecules. One of the things to keep an eye out for in mole-particle conversion questions is that Avogadro's number, 6.022 times 10 to the 23, represents any type of particle. And particles might include atoms, it might include molecules, as this question does, or it might include formula units when we're talking about an ionic compound. These are all different names for different types of particles, but they all are represented by Avogadro's number. So this is asking us how many atoms of N and H as well. So it's a two-part question. The first thing that it asks is how many molecules this many moles is converted to, and the second part is it asks us how many atoms of those individual parts of the formula. So let's start by solving for molecules. Again, solving for molecules is a type of particle, so we're going to use the first formula, and I'm going to write it out without the symbols first. So if we're trying to solve for molecules, which is a type of particle, we can just think about the units that we have in order to figure out what type of calculation makes sense. If I take my moles that were given, the 3.89 moles, and I were to multiply that by Avogadro's number. So if I multiply the number of moles by 6.022 times 10 to the 23 particles per mole, I can analyze that even without memorizing formulas and see that my moles and my moles are going to cancel out. I'm going to be left with particles, which is a general word, but that is representative of molecules that this is asking me for. So that's one way to do it. The other way is to know that molecules can be represented by the large symbol capital M, and that the formula using the mole triangle is small n, which represents moles, times Na, which represents Avogadro's number, which is the way, it's like a conversion factor between moles and particles, because it represents how many particles are in each mole. So if I take my values given, we were given 3.89 moles, multiply that by Avogadro's 6.022 times 10 to the 23, and in this case, it's particles per mole. And then when I multiply those, being really careful here when we put these in with scientific notation. There's a few different tricks you can use. Ask for help if you need some tips and tricks. But when we plug this in correctly to scientific notation, we're going to get 2.34 times 10 to the power of 24. Again, our moles are going to cancel, so we're left with particles, which is a more general word. So a more accurate word would be to call this molecules. Alright, now looking a little further, it asked us also, so that's part one, it asked us how many atoms of N and H. So for each unit of NH3, we have, let's imagine we have NH3. So I'm going to just draw it to visualize. So for every one of these particles here, we have one N. So the number of atoms of N is going to be equal, because each of these molecules has one N in it. So they're equivalent. The number of N equals the number of number of NH3 molecules. But there's 3 hydrogens inside each of these molecules. So the number of atoms of H is going to equal 3 times the number of NH3, because there's 3 H's in the formula in every NH3. So when we multiply this by 3, we're going to get 7.03 times 10 to the 24 atoms of H.